Hello, this video is for IXL Activity 8.V.12. It is titled Properties of Addition and Multiplication, and the 3-character code for this activity is Tango Yankee Lima, TYL. So we're going to look at some properties of addition and multiplication, in particularly commutative property, associative property, the additive identity property, the multiplicative identity property, and then one that's not on this list that we see right here, also the distributive property of multiplication over addition. Wow, that's a really big long title for a property, isn't it? So let's first look at commutative property. Commutative has the root word of commute in it, and commute means to change location. You commute from work to school or from work to house, or you ride a commuter train from point A to point B, etc. So changing position in the commutative property looks something like this. If we have A plus B, that is equal to B plus A. So this is the commutative property, in this case over here, of addition. Now on the right we have the commutative property of multiplication. You see that we're multiplying here, and we have A times B is equal to B times A. You'll notice in both cases A comes first and B second, and then afterwards B comes first and A second. Likewise with the multiplication, they've changed position, or they've traveled from one location to another. Changing position or moving to a different location, that is commuting, and that is the commutative property of both addition and of multiplication. The associative property, our root word for associative is associate, and associating means who do you hang out with, or what group you might hang out in. So grouping in mathematics is done through the use of parentheses. So we see here that we have the same order, A, B, C, A plus B plus C, A plus B plus C. So the order remains the same on both sides of the equation of the equal sign. But here we have A grouped with B, and on the right we have B grouped with C. So we've just changed the associating, or we changed the grouping. So who B is associating with has changed from associating with A to now associating with C. So this is the associative property. We've changed the grouping, and we represent that through the use of parentheses. For the other side over here on the right, for the multiplication side, we still have A times B times C, A times B times C. So you see that the order of the values has not changed. But over here on the left of this equation here, B is associated with A, whereas on the right B is associated with C. So we just changed the association, or we changed the grouping. The additive identity property, A plus 0 equals A. So any number plus 0, that number is equal to itself. For multiplicative identity property, any number times 1 is equal to itself. And then the inverse property of addition and the inverse property of multiplication, we have that here. Inverses take us back to identities. And you notice that x plus negative x, or the opposite of x, equals 0. This is the inverse property of addition because it produces a 0, and 0 is the identity property of addition. So inverses get us to identities. And then so if we take x and multiply it times 1 over x, it's going to give us 1, and 1 happens to be the identity property of multiplication. So the inverse property of multiplication we see here with x times 1 over x. These two here, the inverse properties of addition and multiplication, really don't have to be concerned with it at this time. We won't see that in this activity. So commutative is all about changing position. Associative is same order but different grouping. And then identities for addition is the 0. The identity element of addition is 0. The identity element of multiplication is 1. So let's go ahead and start looking at our questions that we have here. Which property of addition is shown? Indeed, it is addition. We see the plus signs here. So it is addition. We have 5 plus 9 and 9 plus 5. We see that basically the two have changed position over here, right? So that means that they have commuted. and it's the commutative property. Changing position is all about commuting, and that is the commutative property of addition. On the next one, we see some parentheses here, so it's a good indicator of the associative property. It has to do with grouping. Let's first check and see the order of 5, 1, 7, 5, 1, 7. Indeed, the order has not changed. So let's see, 5 is associated with 1, and 1's associated with 7. So 1 has changed its association. Instead of being associated with 5, it's now associated with 7. So this is the associative property. We just did some regrouping, but the order didn't change. Which property of multiplication is shown? So we have 7 times 3 and 3 times 7. Notice that 7's the first factor and it becomes the second, and 3 goes from being the second factor to becoming the first. So we've changed the order. That means that things moved. To move means to commute, so therefore it is the commutative property of multiplication. Which property of multiplication is shown in our next question here? Well, first check the order. We have 4, 7, 2, 4, 7, 2. So it does not appear that the order has changed, so we can rule out the idea that it is commutative property. Let's see, 4 and 7 are associated together, and 7 and 2 are associated together. So it does appear that the 7 is no longer associated with the 4, it's now associated with the 2, so this is definitely going to be the associative property. We know it's not the identity property because multiplication, we'd have to have a times 1 in there someplace, right? In distributive property, it's not that. We haven't quite gotten to the distributive property yet, but we soon will. Here we have I have an illustration of a man looking in a mirror. So that is to help us understand the identity property. We know that whenever a number, just like a man here, the man looks in the mirror and sees himself. So a number looks in the mirror and that number sees itself. If in the event that it is addition, if we're adding, then that's going to be a plus 0. Any number plus 0 is equal to itself. But if we're multiplying, then it's going to be the value of 1. It's going to be times 1, right? That's not a subtraction, that's a dot for multiplication, so times 1. So any number plus 0, you're going to get that number back, and any number times 1, you're going to get that same value back. Just like the man looks in the mirror and sees himself, the number looks in the mirror of addition. If it's a 0, it sees itself. If it's looking into the mirror of multiplication, that's times 1, it sees itself as well. So here we have 7 on the left and 1 times 7 on the right. So 7's being multiplied times 1 to get a 7. So this is indeed the identity property. Not commutative because nothing's changed places. Distributive property we haven't talked about yet. And associative property, we don't have any parentheses going on. This is an identity situation. Now we have which property of addition is shown. Well, we know that plus 0 is the identity property. 8 is added to 0. It's looking in the mirror and seeing itself. So this is the identity property. We have no parentheses, so we know it's not associative property. And we don't have numbers changing position, so it's not the commutative property either. All right, for this next one, we have the distributive property. Which property of multiplication is shown? So what is the answer to, let's see, how do I want to go about this? Let's look at the picture up here. We have a little scale, and it's showing that two things are balanced. And we have that A times the quantity of B plus C is equal to A times B plus A times C. So A is being multiplied times B, and it's being multiplied times C. And we group those here and here. And we have addition in between it because between B and C, it's addition here as well. So with that in mind, we look down here at what's this look like. This is using algebra, right? Using variables to represent this concept. What do we use? Actual numbers. So 2 times the quantity of 4 plus 3. That's the same thing as 2 times 4. And I'm going to use parentheses here. 2 times 4 because it's being multiplied times the 4. And the 2 is also being multiplied times the 3. And we get 14. Now we can double check this and verify it, because 4 plus 3 is 7, and 2 times 7 equals 14. So this part of it here is good to go. Well, what about this? Well, order of operations says we need to multiply first, then we can do the addition. 2 times 4 is 8, 2 times 3 is 6, and 8 plus 6 is 14 as well. So we see that it is a true statement that these equal each other. So we have this equals this, which equals this, right? So we know that these two are equivalent. 2 times the quantity of 4 plus 3 is equivalent to 2 times 4 plus 2 times 3. We call it distributive property because long ago I used to deliver newspapers. It was the exact same newspaper that went to every house. I had a list of houses. These are the houses you have to take this newspaper to. So it's like 2 is the newspaper, and what's inside the parentheses is like the houses. So 2 goes to house 4, and it also goes to house 3. Here 2's going to house 4, and here 2's going to house 3. And it is multiplication's the operation, and then it's separated by the plus sign because it's a plus sign between the 4 and the 3. Hopefully all of that helps. So we're looking at, and chances are the answer is distributive property, right? Because that's pretty much what I'm talking about. However, let's look at this here. On one side, we have some multiplication, right, and addition. So we know that order operation says we have to multiply these first. Now we see that the 2 shows up as a factor of each one of them. So it's kind of like the reverse of, it's like reverse distributive property. We could pull that 2 out of each of these and end up over here, right, outside of it. And then that would leave us with the 3 plus the 0 in there. So the 3 plus the 0 is left behind. So here we see the 3 and the 0. It is addition in between. And the 2 is the factor that's been pulled out. So this indeed is distributive property. It's kind of like the reverse of distributive property here. On this one here, I have the 2 and I'm distributing the 2 in and multiplying it times the 4 and the 3. Here, we're going the other way. Instead of putting it in, we're kind of pulling the 2 out of it like I'd done. So the 2 comes out, and the 2 comes out. Now it's just a 1, 2 out here by itself. And then we have the 3 plus the 0. That's what remains. The 3 and the 0 and the plus sign. The 3 and the 0 are in the inside there. Commutative property, no, we didn't have things change in location. Associative property, that could get kind of tricky because whenever you look at it, like, oh, look, there's parentheses involved right here, right? So it's associative property, not necessarily always true. And some people might jump on identity because they see the 3 plus 0 there, but you got to look at the whole problem. So in this case, this is the distributive property. On the next one, which property multiplication is shown here? So I've got some multiplication and some subtraction here, right? So what's common? Well, both of these have the factor s in it. So let's pull the s out of it, right? And then we end up with the s over here. What's left over gets put in its own set of parentheses we see here, which is the q and the r, and this is subtraction that's there. So that's why we have the subtraction sign here. And this is indeed the distributive property. On the next one, which property of multiplication is shown here? We do see the dot, so we know that it is indeed multiplication. Okay. And we're looking for what's going on here. Well, there's no parentheses, so I don't think it's, not check mark X, I don't think it's commutative. I don't see no plus 0 or times 1, so it's not identity. And I don't see a whole lot of that, all that movement of distributive property stuff, so it must be associative property. Correction, wrong. I got ahead of myself, didn't I? Trying to get through this video. I'm watching the timer ticking down there in the corner. No parentheses, so things aren't being associated. But it is commutative. We do see that k, the first factor, becomes the second, and m, the second factor, becomes the first. So things are changing position. So it is the commutative property. Commute means to change position and move. Here, this is probably associative property because I see some parentheses going on. So let's check. TUV, TUV. Indeed, the order has not changed, so it is not commutative. Nothing to do with identity because we don't have a plus 0 or times 1, and therefore it must be associative. Here the T is associated with the U, and now the U is associated with the V. It is indeed associative property. Here's our plus 0, right? So 0 plus n, or we could look at this as n plus 0. We can use the commutative property to switch those, right? Switch those around. But the answer is not commutative property. We're just commuting this first side so we can see that we are adding 0. So 0 is the identity element of addition, and this is indeed addition, and that means that it is the identity property. On the next one, looks like BCD, BCD. Order has not changed. Everything's in the same order, so it's not commutative. I don't see any plus or times 1 and plus 0 going on. So this must be associative property, and here C is associated with D, and here it's associated with B. So we've just reassociated it. Here we have the K, and this one looks familiar. I think we've done this one already. K is the first add-in. Oh, it's probably multiplication. K is the first add-in. It now becomes the second. M is the second add-in, and it now becomes the first. We've changed their order. That means that they moved, that they commuted. It's commutative property. Which equation shows the identity property of multiplication? So we're looking for multiplication. We can rule out, there's multiplication in all of them, so we can't really like cross out all the addition problems. But this is, oh look, P times 1 equals P. And we're looking for identity property, so there it is right there. This, nope, not that. This one here, notice this is, hopefully you recognize this one here as distributive property, where the R is coming out on both of these, leaving behind the P and the Q in addition. So we have the P and the Q in there. This is distributive property. And then this one here, PQR, PQR, some regrouping going on. This is the associative property, which shows the distributive property. Well, if you're recognizing this, the one with parentheses on one side but not the other side, you'd probably be right. So we see here that we have the factor P can come out of both of these, and so we get that out by itself, and then we're left with the M and the N, which we see there, and it is addition, so the plus sign is the correct sign there. So indeed this is the distributive property. This is like no property. It's closure property actually, but we won't go there. Nope, there's no particular property there, and this would be the identity property. We'll call that ID. And my final question here, which one shows the commutative property of addition? Remember, commute means to change places. So looks like K is the first here, and now it's the second. J is the second, and now it's the first. It is indeed, looking for addition, it is indeed addition. So we're good to go on the operation. It looks to be that this is the correct one. Let's double check the rest of them. This is the identity property of addition, and this is the identity property of addition as well. And this down here looks like JKM, JKM, just we got some reassociating going on. So this is the associative property here, using these parentheses there. All right, so that's everything on IXL 8.V.12, properties of addition and multiplication. Good luck on your activity.